There is a bridge in China that trucks cross every day, 300 meters above nothing. No riverbed below, no valley floor, just canyon and fog, and a 50-story drop into empty air. Engineers looked at that gorge in Guizhou province and said it couldn't hold a road. China built one anyway. There is a highway that runs under the ocean floor, surfaces on an artificial island, then dives back underwater to dodge one of the busiest shipping lanes on Earth. Naval architects said the pressure differential alone would crack the seals within a decade. China built it anyway. There is a railway that had to cross a mountain range so young, so violently unstable, geologists nicknamed it the Earthquake Museum. The rock moves while you tunnel through it. China is finishing that railway right now. 3 projects, 3 verdicts of impossible. 3 times the verdict got ignored. Before we go further, drop a comment and tell us where you're watching this from. Let's find out how they actually did it. Case study 1. The bridge that shouldn't exist. Guizhou province is karst country. Limestone eaten hollow by a million years of acid rain, riddled with sinkholes, split by gorges deeper than the Grand Canyon in some stretches. For centuries, villages 12 miles apart as the crow flies were a full day's journey apart by road, because no road could survive the terrain between them. Standard bridge engineering has a hard ceiling. Suspension cables lose tensile efficiency past a certain span-to-height ratio, and wind shear at 300 plus meters becomes structurally unmanageable for conventional towers. Western engineering firms that surveyed the Beipanjiang Gorge in the early 2000s filed reports calling a crossing economically irrational. The cost per mile would be 10 times a flatland highway for a road serving a population too small to justify it. China's answer wasn't a bigger bridge, it was a different sequence. Engineers fired steel cables across the canyon using rockets because no crane could reach that far. Those pilot lines then hauled the main cables across in stages, anchored into bedrock instead of surface towers, spreading the load into the mountain itself rather than fighting it. The deck was built from both cliffs simultaneously, meeting in the middle to the centimeter. The result, the Beipanjiang Duge Bridge, over 1,850 feet above the canyon floor. Tall enough to stack the Empire State Building underneath it with room to spare. A journey that took 5 hours on switchback roads now takes 2 minutes. Guizhou now holds more of the world's highest bridges than every other region on the planet combined. Case study 2. The road that dives under the sea. The Pearl River Delta is one of the busiest maritime corridors on Earth. Container ships every few minutes, typhoons every season, and a seabed that shifts with every tide. Connecting Hong Kong, Macau, and Zhuhai by bridge alone was rejected outright. A single continuous span would have forced ships to either halt entirely or squeeze through impossibly narrow gaps, choking a trade route worth hundreds of billions a year. The mathematical breaking point was simple. You cannot put a bridge pillar in the middle of an active shipping superhighway and expect global trade to route around it. So they removed the bridge from the shipping lane entirely. Engineers built 2 artificial islands out of the seabed, sank a 4-mile tunnel between them, 30 meters under the ocean floor, then reconnected the tunnel to bridge spans on either side. The tunnel segments, each one over 80,000 tons, heavier than an aircraft carrier, were built onshore, floated into position, and lower by GPS-guided precision to sit within 4 millimeters of blueprint. Rubber gaskets the width of a hand seal each joint against pressure that would crush a submarine hull if the tolerance failed. The Hong Kong-Zhuhai-Macau Bridge is now the longest sea crossing on the planet, 34 miles, engineered to survive a magnitude 8 earthquake and a category 16 typhoon. A ferry trip that once took 4 hours is now a 30-minute drive. If a mountain bridge and an undersea highway sound extreme, stay with us. The next one is a stranger, and it's still under construction. Subscribe now, because we track every one of these builds as they happen. Case study. 3. The railway through living rock. The Sichuan-Tibet Railway has to cross the Hengduan Mountains, where 4 tectonic plates grind against each other and the elevation swings nearly 2 miles within a 50-mile stretch. Geologists call this stretch a museum of every geological hazard on Earth. Landslides, glacial melt, permafrost, and rock so unstable it deforms mid-tunnel, closing gaps that were open the day before. Previous rail projects through similar terrain in other countries simply rerouted around it, adding hundreds of miles rather than risk tunneling through moving ground. The verdict here was blunt. Standard boring techniques would collapse before completion, and the altitude alone, over 13,000 feet in places, makes construction equipment lose a third of its rated power. The workaround is a rotating drill and monitor loop. Sensors read rock pressure in real time, adjusting tunnel lining thickness meter by meter instead of using one fixed design. Essentially building a different tunnel every few hundred feet based on what the mountain is doing that day. Reinforced concrete segments are precast off-site, air lifted in, and locked into place within hours of excavation, before the exposed rock face has time to shift. Picture this. Crews working inside a tunnel while the walls around them are still actively moving, millimeters a day, and the structure has to be engineered to flex with it rather than resist it and crack. Drop a comment. How would you even begin solving that? Once complete, the full Sichuan-Tibet line will cut a 2-day mountain journey down to under 8 hours. The pattern behind the impossible. 3 different terrains, 3 different disciplines, 1 identical playbook. Identify the exact point where conventional engineering gives up, then build a custom solution for that single failure point instead of abandoning the project. The deeper answer is about timing, not just technique. Most infrastructure gets built to catch up with demand that already exists. China builds the infrastructure first, then lets the demand grow into it. A bridge exists before the town on the other side is large enough to justify one. A railway gets laid before the trade route is proven, betting that access itself creates the economy rather than waiting for the economy to request access. The terrain said no. The cost projections said no. Outside engineering firms said no. In writing, on the record. Over $250 billion has gone into ignoring every one of those verdicts, and the bridges, tunnels, and railways are standing, running, and expanding right now. If this kind of engineering defiance is your thing, hit subscribe. We're covering these builds as they happen, one impossible mile at a time. Before you go, drop a comment and tell us which one of these 3 should be ranked hardest to build. We'll pin the best answers.